Okay, so for this video, we are going to discuss all the details for circular measure like our chapter 4. Alright, so in the previous video, we already learned some very common formula and also the rules that we are going to use in this chapter. Okay, so for this chapter, mainly we are going to cover how to answer the application question that usually they will ask in the real exam. Alright, okay, so let's have a look. Okay, generally what you need to know after this session is you need to know also what's the meaning of the radian. Okay, so radian is actually another unit of angle. Usually when we learn angle, right, we learn about angle in degree most of the time now. And then for now, they are going to introduce the angle in radian. Alright, so if you learn circular measure in SPM or maybe in your previous syllabus before, right, you should know what is the meaning of radian, right? Okay, so you have to also know how to convert the radian become degree and how to convert the degree become radian. Then after that, you also need to know how to apply the formula for the length of arc, which is S equals to R theta, and also A equals to half R square theta. So A equals to R square theta means that the area of a circle, the area of the sector, sorry. And then for the S is actually the arc length. Alright, so you need to know all this okay, after this session, right? Okay, so let's start with some very basic definition. So first, you need to know what's the definition of a circle. And I think in the previous video, I already showed you, right? Okay, how to I already sketched a diagram, and I believe that you already know what is the meaning of all the words here. Okay, so all this word is very common. You will see it very commonly or very frequently in the circular measure question. Alright, so for me, I'm not going to continue or repeat again for this part. So if, let's say, you don't really understand, you go back to the previous video. Alright, okay, then after that, let's have a look for the definition of radian. So when they're talking about the definition of radian, right, when they created the unit of radian, their idea is like this. So they are actually thinking about, if let's say you are having a circle and you're having a center, alright, so they said that, okay, the radius is a 1. Okay, when you're having the radius 1, and they said that the length of the arc is also 1 unit, and therefore the angle that we have here is also 1, and they call this as 1 radian. So that's the definition for 1 radian. Okay, so that's the meaning. So when they try to create it, so this is how they define. Alright, okay, so after they prove it, right, they realize that, okay, when you are having pi radian, it is equal to 180. So how they prove this, I also don't know. If you're interested, you can just go online and search for it. All right, I also curious, okay, how they actually know pi is equal to 180. I believe that there are some proving. Right, you can just go and have a look if you are interested. Okay. Right, then after that, this is an important thing. You should know how to convert a radian become a degree. So to convert a radian become a degree, you need to multiply it with 180 divided by pi. Okay, if you want to change the degree, become the radian, then generally what we have is pi. Multiply pi with 100 and divided by 180. Okay, so this is an important process. So just make sure that you know how to convert it. Okay, so make sure that you know how to convert this correctly. All right. Okay, then after that, another important thing is you need to know how to calculate the length of an arc. So the length of an arc is S equals to R theta. So please take note that the theta here should be in the unit of radian. If let's say they tell you that, okay, this theta is 30 degrees, so you cannot put a 30 here, you have to convert it into a radian form, then only you can substitute it. Okay, and also the same thing, they ask you to calculate the area of a sector. Generally, it is equals to half R square theta. Then again, the R square theta, the theta here should be in the unit of radian. Okay, so the area basically means this one. This is the area of a sector. So half R square theta. Okay, and then when they are talking about the length of arc, means that this one, sorry. So the length of arc is actually this length. Okay, so the formula will be R theta. Okay, so these are the two important formulas that you need to know, okay, to find out the perimeter, sorry, the length of arc and also the area. All right. Then after that, besides these two important formula here, and I think I told you in the previous video also, there are some useful formula in this chapter also. There are sine rule, cosine rule, and also the area of triangle. Okay, so all these formulas, just make sure that you know how to refer to the triangle and how the formula look like. All right, so these three formula, I'm not sure whether they will give it to you in the formula booklet or not. Maybe you can have a look. All right. So let's start with the application question now. So generally, this is what we want to cover for this chapter now. Okay, very short. It's a very, very short chapter. Just that now you need to know how to answer all the questions here. Okay, right. So let's start. All right. So for this example number 1, it is a partial question. So they give the figure like this, and then they say that it is a OCD is an isosceles triangle, and then the OC and OD is equals to 10 cm. So you can refer to the figure. What does it mean? And also the angle COD is 0.8 radian. All right. So the point AB of OC and OD respectively, they join by an arc of a circle with the center O and the radius 6 cm. So this is a paragraph to describe what they give you in the figure here. All right, so now first they want you to find the area of the shaded region. Okay, so to calculate the area for the shaded region, what can we do? Okay, so to calculate the area of the shaded region, you can see that you are actually going to use the triangle area. This is the area of a triangle, right? Minus the area of the sector. This is a sector, right? Okay, and therefore, after you take triangle minus the sector, then you will get the shaded area successfully. All right, so if you want, you can write it out in your step first. So this is the area of the triangle minus the area of the sector. All right, after that, what is the area of triangle? So the area of the triangle, right, there are a few formulas. This is not a right angle triangle. So you can use the formula that we learned before in the previous video, half AB by C. So I'm going to use this length and also this length, sine the angle here, because this is the angle that have 0.8, right? Therefore, I will use half. A means 10, B means 10, sine C means sine 0.8. Okay, and after that you have to minus the area of sector. So how to minus the area of sector? Half. Okay, then R. Oh, sorry, your R is not 6 here, right? Because if you refer to the green part, maybe I can erase this. If you refer to the green color part, you will see that the radius is 6 only here. Correct or not? So you can take minus half R square, means 6 square theta. So your theta is 0.8. Okay. So you can see that the data that I put is in the unit of radian one. So I'm using the 0.8 here. Okay. All right. Then after that, you can just press the calculator and see whether you will get a value or not. So the value that you get should be 21.5. Okay. So if you want to get 21.5, there are a few things that you need to know. Okay. So first, if you write out sine 0.8, this is sine 0.8, right? In your calculator, you should put it in the radian mode. I don't know whether you know how to apply it in the radian mode or not. So maybe during the face-to-face class, I will show you lah. Okay, maybe let me have a look. I already forget. Okay, usually if you want to change it become radian mode, right? You just press shift and then mode. Okay, so shift and mode. And then after that, for those who are using ES calculator, you should see something like this. You look for RAD. RAD means radian. So if you change it to become radian, right? So on top of your calculator, you will see this sign. If you didn't change it, it will be originally look like a degree. Okay, so when you press sine 0.8, if you want to get the correct answer, because 0.8 is radian, right? So you have to keep it in the radian mode. Okay, so if let's say you still want to use the degree mode, that means for this 0.8, when you want to, you have to change it become degree. But the data here is still the radian. Alright, so usually I will tell students if you don't want to be very confusing, right? So just change your calculator become radian. To me, it will be much more easier. Okay, so for any sine, cos, tangent, if let's say you've got trigo function with the radian value inside here, then generally you have to change your calculator in the radian mode. Okay, so some students, they feel I don't like, I want to use degree and I keep it as a degree mode. Can also, but I can tell that maybe in the later chapter, you found it is very troublesome. So I would strongly suggest you that try to use the radian mode and try to figure out how to use the radian mode correctly. Okay, so you try and figure out and see how. Alright, so as long as you see any trigo function with the radian unit in the angle, then generally you need to use the radian mode for your calculator. Alright, okay, then now let's continue to part number B. Okay, so for part number B, what do we have here? So they ask you to calculate the perimeter of the shaded region. Alright, so if I want to calculate the perimeter for the shaded region, right, you will see that I need the length for CD, I need the length for AB, and then after that AC I have already, which is 4 cm, BD which is 4 cm also. So I need to calculate AB and CD first before I can get the final answer. Alright, so I will start. What is AB here? So AB generally is the length of an arc, right? So the length of an arc is r theta. So what is the arc? 6 cm. Because AB is formed by the radius 6 cm, right? Okay, so it is 6 and then theta is 0.8. So this one very straightforward, it is 4.8. Okay, so to find the CD, the length of CD, okay, so you can refer to the whole triangle here. You have the length for two sides and also one angle. So maybe the suitable formula that you can use is the cosine rule. So what's the cosine rule here? It should be CD squared equals to tan square plus tan square minus 2AB cos 0.8. Okay, and then after that, if you want to get the CD, it should be the square root of this whole thing. Okay, and then your CD value 7.788366846. Okay, so again, if you want to get the value that I show you here, you will see this one again. Now it is a trigo function with the radian degree. Oh, sorry, the radian angle, right? So if you want to get the correct answer, please keep your calculator when you're pressing the whole part here in the radian mode. Okay, all right. Then after that, because the CD is the final answer yet, so usually I will keep it as long as possible. Then eventually only I try to rephrase and add up everything. So what is the perimeter? So perimeter means that you have AB. So AB is 4.8 plus CD, which is 7.788366846 plus AC, which is a 4 plus BD, which is a 4 also. After that, the last step, only you try to simplify it, become three significant figure, which is 20.6 cm. Okay, so you can have a look that, okay, now this question generally is not hard because it's quite straightforward. It asks you to just find out the area of the shaded region and also the perimeter. Okay, but of course, you need to learn how to use the length of the arc and also how to use the sector area formula. And also, here we apply actually the cosine rule. Okay, so I hope that you roughly have the idea how to do this. It is not hard, right? Okay, so next, let's continue example 2. Okay, so for example 2, again, they give you a very nice figure also, and then they try to ask you to answer some question based on this. Okay, so let us start. Okay, so here they tell you that in this diagram, blah, 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 and so on, the center is O, and the radius is 12 cm. The line AX and BX are tangent. Okay, so AX is a tangent to the circle. So how would it look like? That means this is a tangent, so that means pass through the A, and then the circle will look something like this. This is a circle. And so that's why the AX is a tangent. Okay, so I think last time we told you also, right, when you're having AX is a tangent and then connected, the point A connected to the O, what happened to the angle? between them. All right, so the angle is actually a 90 degree here. I hope that you can see it clearly. And then for BX also the same thing. If this is the tangent, you can imagine that this is a tangent, and then the circle will look something like this. So this is a point. Okay. And then when you take the point connected to the center also, you will see that it is a 90 degree. They are perpendicular to each other. Therefore, this is also a 90 degree. Okay. All right. Then after that, they tell you that AOB is pi over 3 radian, which is 60 degree. So this is 60 degree actually. All right, so now first they want to find the exact length of X, and after that they want to find the area of the shaded region. Okay, so no matter what you want to find out first here, if you look at this whole thing, it looks like a kite shape in general. Okay, but to me, right, kite shape doesn't help us much in doing all the calculation. You maybe can try to consider, okay, to cut this whole part into half. Okay, so if I cut this whole part and this whole figure into half, right, you will see that actually it consists of two right angle triangle. Can you see that? Okay, so these are two right angle triangle here. I hope that you can see it. Okay. Yeah, and you should know that this is 12 cm because it is the radius. And then you cut the angle into half, right? So you'll become pi over 6. So both are symmetric actually, all right? Because I think you can see it's very clear, all right? Both are symmetric. And then for this one, the length here is actually hypotenuse, okay? All right, so now if they want you to calculate the value for AX, and please highlight the word exact. Okay, when they tell you that you are having exact length, okay, what does it mean for exact length? So exact length means that your final answer shouldn't be in a decimal number. It should be either in a sub form or either in a fraction form, or pi or whatever. Okay, so how to get the exact value for AX? So I can refer to this triangle. If you refer to this triangle, right, you will realize that you can use the result tangent pi over 6 is equals to AX divided by OA, which is a 12. Therefore, very easily, you can get the length of AX. So 12 tangent pi over 6. Okay, so if let's say you're using ES calculator, right, then generally you can get the idea, the value for tangent pi over 6 very easily, and end up you can get the answer very easily. If you are using the MS calculator, then you can refer to the triangle that we learned before. Okay, so just before that we learned 30 degree, right? So the 30 degree here is 1, 2, square root 3. Okay, so 30 degree is also actually the pi over 6. Okay, so if they want to have pi over 6, okay, tangent pi over 6, what's the value? It will be 1 over square root 3. So you're having 12, 1 over square root 3. Okay, so I think I told you before, right? We actually don't like to have the answer with sub form at the denominator to rationalize it. So how are you going to rationalize this one? So you multiply it with square root 3 and also square root 3. Okay, so when you multiply it with square root 3 and square root 3 on top and bottom, then generally you have 12 square root 3 divided by 3. Okay, divided by 3. And then after that, if you further simplify, you will get 4 square root 3. So this is actually the exact length for AX. Okay, so of course, if you are using ES calculator, right, you can skip this one because you don't need this to help you. And you also don't need this to help you. All right. So you need to run through or go through all the rationalized method. But if, to me, right, if let's say you're using MS calculator, you learn extra things here. So that's why, to me, I still prefer students to use MS calculator. Although it's a bit troublesome because some students will say, I need to learn a lot of things. But to me, right, when you learn basic things here, it will be very useful in your solution someday. All right, so I will prefer you to learn up all this. Okay. All right, so this is why we have a 4 square root 3 as the length of AX. So I hope that you can see clearly. Okay, all right. So now I know that this is 4 square root 3 already. Okay, then the second part, what they want you to calculate. So for the second part, they want you to calculate the area of the shaded region, and then giving your answer in terms of pi and search from. So that means you also need to have the exact value. Okay, so how to get the shaded region? So to get the shaded region, maybe you can consider to take this one. This is a right angle triangle minus what? You can use it to minus. You can use it to minus the sector area. So this is a sector area in green color. Okay, and that's why after you take triangle minus the sector, then you'll get the shaded area, right? And then it is part of the shaded area only. So to get the complete answer for the shaded area, you have to multiply it with 2. So this is the first part that you get and multiply with 2. Because these two areas should be the same. Okay, all right. So you roughly know how to do it already, then we can start. Okay, so for part B, to find out the shaded area, what we do is you have to take 2 multiply with what? 2 times of what? 2 times of area triangle minus the area of sector. Okay, so I will start now. Area of triangle is half, multiply with base, multiply with height. Then minus the area of sector. So the area of sector will be half r square. So it will be 12 square half r square theta. So as the value of theta, pi over 6. Okay. So from here, if you try to simplify slowly, then you have 2 multiply with 24 square root minus 12 pi. Okay, then eventually, of course, you can multiply it in. Okay, so when you multiply it, you will have 48 square root 3 minus 24 pi. Okay, so this is what we have for the shaded area answer. Okay, so again, you will see that when you try to answer this question, you need another extra knowledge here maybe. That is the value of the triangle with the pi over 6 as one of the degree. Okay, so you can see that these two examples that we discussed here is not hard actually. If let's say roughly know what are you going to use in the solution. Okay, but also they will ask you some hard question also. Okay, so it depends on your luck also for the exam part. Yeah. Alright, so I'll stop here for this video. Okay, so next video we are going to discuss another 2 examples in this chapter, chapter 3 and also chapter 4. I think chapter 3 we need a longer time to solve it. Alright, chapter 4 very easy, you can solve it very easily. But chapter 3, I think maybe we have to discuss about it a little bit more. But maybe before you view the next video, right, you can try the example 3 and 4 first, maybe. Example 3 is quite challenging, not to say challenging, but maybe the step is a bit more. Alright, so maybe you can have a try, then only you go to view the video and see what is the solution. Alright, so thank you for your time. We are going to stop here for this video.